I think for me it must have been like when we landed on Mars and opportunity opened up and started roving around. It worked. But for me, going to the bottom of the ocean for the first time and seeing for the first time perhaps new life, new species, new snails, new mussels, new tube worms, and of course new microbes is super exciting. It's always this sort of like, wow, nobody has ever been here before. And always there's a new discovery, several new discoveries every time we go to a new place. We've only explored maybe 1 to 10% of our sea floor. So there's a lot more to be discovered at the bottom of the ocean. I'm Anna-Louise Reysenbach. I'm a professor at Portland State University. I am a microbial ecologist. What I work on are organisms that are thermophiles. Thermophile means heat-loving organisms. So these are organisms that live at temperatures that we couldn't live at, and most animals and insects cannot live at. So this is above 60 degrees Celsius, which is 120 Fahrenheit maybe. They're known as extremophiles because it's extreme conditions compared to what we know on the planet that we live in. These organisms grow in hot springs all over the world, like in Yellowstone, and also the bottom of the ocean where there's very hot water. A lot of these organisms live there. When you think about early Earth, right? The early Earth, when it formed, it was this big explosion, and then it was this very volcanically active environment. There were meteors bombarding, there were volcanoes everywhere, and it was hot. It was really, really hot, gaseous environment. No oxygen at the time. And under those conditions, probably early Earth arose in these little hot springs. Microorganisms arose and could use the chemistry to then be the first forms of life. A lot of these high temperature environments are quite extreme. Like at deep sea vents, there's 4 degrees Celsius water on one end and 400 degrees Celsius in the middle of these hydrothermal chimneys. And the gradients that these organisms have to live along are very short. So they're having to really deal with temperature gradients, pH gradients, chemical gradients, turbulent waters, earthquakes. So they're supremely adapted to these extreme chemical, physical gradients and thrive, absolutely thrive, grow very fast under these conditions. The hydrothermal fluid is coming up, mixing with cold seawater, and the moment that high temperature fluid mixes with cold seawater, the minerals precipitate out of solution, and the minerals just flop out of solution, and they form these structures that look like chimneys, and that are very porous. These things they're very fragile, and so they're very porous, and so microbes can just colonize these lovely little jacuzzis bathed in hydrothermal fluid. The really cool thing about some of these organisms is that they can live without light energy. And prior to the discovery of deep sea hydrothermal vents, we all thought that life was driven by the energy of the sun. And so in this case, at deep sea vents, the life is driven not by light energy, but by geochemical energy coming deep within the Earth's crust. And the geochemical energy is part of the hydrothermal fluid, the hot water that's coming out of these hot springs at the bottom of the ocean. And that is exactly the secret to supporting the life that we see at these hot springs. is my microbial zoo. So here all the microbes were growing from all over the world. Some of these are from, Iceland. These are from deep sea vents. These organisms are from Yellowstone that they're growing in here. These are thermoacidophiles, heat-loving, acid-loving organisms. So these grow at pH of 4 and lower. There's no other hot spring environment in the world that is as diverse and unique as Yellowstone. There are more hot springs in that park than any other similar environment on this planet. It's also, there's this huge range of chemistries from high pH hot springs to very low pH hot springs, huge ranges of temperatures. It's the greatest diversity of hot springs, no doubt, anywhere in the world. So the one really different thing between deep sea vents and Yellowstone hot springs is that you've got light. Okay? And so in the deep sea you don't have light. So in Yellowstone you see these beautiful arrays of colors, and these are called microbial mats. The array of colors that you see are based on the kinds of organisms that are living at different temperatures. Studying these thermophiles, it's not only just studying the unknown, but once we've got these organisms in culture, or once we know what they're doing, their enzymes, so the proteins that they have, that they make, a lot of them have great industrial applications. The big enzyme that is a multi-billion-dollar enzyme is called thermophiles enzyme. It's Taq polymerase, it's thermophiles polymerase. And that enzyme makes multiple copies of single genes. It's used in detection of diseases. It's used in forensics for tracking down criminals. The reason why we can now sequence the entire human genome ultimately was as a result of thermophiles. And this organism was originally found in Yellowstone in the 1970s or 60s, and it sat in a culture collection for many, many, many years until some scientists decided, oh, we need a thermostable enzyme to do this reaction, to get this little gene. And so they developed this new enzyme that then became a multi-billion-dollar enzyme. Why don't you use 2 microliters in there? 2, all right. I don't know. It was really exciting to be part of this beginning of discovery of new life forms, because most people didn't expect to find life growing at temperatures of boiling water. And so it totally changed our view of what was possible, how life was possible at temperatures over 180 degrees Fahrenheit. Organisms were thriving, and that really blew apart our concept of the extent of life on this planet. So I think there's definitely possibility for life outside our planet, or life as we know it outside our planet. So long as there's water, and so long as there's an energy source and a carbon source, we should be able to find life. I think it's what drives us to always be excited about thinking that maybe we're not alone in the solar system and that there's something potentially else out there. The more we look at other planets, the more this looks like an oasis. I think we have a role to play as educators to inspire the next generation to take care of this planet, you know. So the more we get kids out into the open and exploring nature, the better too, because they're gonna be the next stewards of this planet. Not me. Me a little bit, but it's the next generation.